The first part of the review here should not be any breaking news to you. It's going to be 7 questions, 30 points. First 3 questions are going to be multiple choice, 4 word problems right after. Okay, 4 word problems right after. They are lengthy word problems. It might be a part A, a part B, or it might be just one question, but you got to find this side to get to this side to get to the final side, which is the one I wanted in the problem. All right, so it is going to that's why there's only 4, because it's probably going to take you the full time to do all 4 of those. How you do them, I don't know. Is it Hill-Sass? Is it one of our special right triangles? Maybe you want to use SOHCAHTOA, or maybe law of sines and law of cosines. I just want to remind you guys, if you are going to use law of sines or cosines tomorrow, good, but I'm not going to give you those formulas. So that's up to you to remember them while you're taking the test. All right? So what I'm going to do today is I'm going to go through each of these pieces in a lot more detail than just listing them out like I have for you right now. I am not going to do any problems. All right, that's for you to do on your own or for you to bring to the review today. I am not doing any problems. Like I said, I'm going to go one by one here and go and do a lot more detail of what did we talk about during those days we did it. Kyla, what do you got?
Are we going to have to know the law, like which is if you do Pythagorean theorem and in the hypotenuse and C is longer than the other 2 sides, then it's like.
Oh, no.
Okay.
Nope.
Oh.
What I have up here is that's it. Okay. I know there's other stuff too. Kyla just asked, hey, what about using Pythagorean theorem to tell if a triangle's acute, obtuse, or right? Nope. The stuff we did where the sine of an angle is equal to the cosine of its complement, like cosine 40 equals sine of 50, that won't be on there. All right. This is exactly what's going to be on here. So let me start with Hills and Sass. Okay. It's going to come up tomorrow. All right, we just got to recognize, hey, I might have to use Hills and Sass for this. So let's talk. Tomorrow on the test, when would I need to use Hills and Sass? Well, I'm going to give you probably a diagram that's going to be a right triangle. In that right triangle, you are going to see an altitude coming from the right angle. And as we know, how am I going to know it's an altitude if I don't state it in the directions? Altitudes form right angles. So I'm going to see right angles there. So that is the type of diagram I can use Hills and Sass on. A right triangle with an altitude coming from the right angle. All right, let's now help me label all the different parts here as far as the H, the L, the S, and the A. H is for hypotenuse. What am I talking about as far as the hypotenuse on this diagram? Well, you got 3 of them because you have 3 right triangles. But the one we're going to use in Hills is AC, the hypotenuse of the big right triangle. That's hypotenuse when we talk Hills. L for legs. What am I talking about as far as the legs? The legs of the big right triangle. AB and BC. That's what I'm talking about as far as the legs go. Notice when I drew the altitude in, didn't I create 2 segments on the hypotenuse? AD and DC. Those are the segments. And then finally, BD. I just saved that for last because we already talked about what BD is. That's my altitude. Okay, that's my altitude. So there are the different segments. Or different, I should say, I don't want to say segments. Different parts of a Hills-Sass. Hills! H for hypotenuse. We just talked about where that is located in this diagram. So whatever that length is, we'll go right there. There's my hypotenuse. L for leg. Anybody want to tell me about the 2 legs in Hills? Or remember the 2 legs? They are the same. Even if you forget that, please remember. In a proportion, anybody remember what these 2 were called in a proportion? Means. They're called the means. The means are always the same, whether you're using Hills or Sass. All right, so that tells me the legs are always equal. And then S for segment. But hey, help me. What segment? Because I got two of them I labeled. What segment am I talking about? The segment adjacent to leg being used. Okay? I'm going to plug in the segment to the leg being used, adjacent to the leg being used. So there's hills. And then you also have, maybe that won't work, SAS. S for segment. What do you know about the two segments in SAS? Different. The extremes are different. But the A is for altitude, which are the same. And they have to be, don't they? Because you only have one altitude, so it has to be the same. All right, so there's hills and SAS for you kids. Hills and SAS. Any questions on hills and SAS?
Would you give a word problem using hills and SAS?
What's that?
Would you give like a word problem?
Could be a word problem, could be multiple choice. I'm not giving much away here on this one. All right, but it will come up. All right, guys, I'm not wasting your time here today. I'm doing this because I know it's going to come up somewhere. Either multiple choice or part of a word problem or a word problem. Questions? Now, I also want to mention you have 3 right triangles. What is also a valid option here other than hills and SAS maybe? Pythag. Okay, Pythag. Okay, hills, SAS, Pythag's always an option too because you're dealing with sides of a right triangle. Any issues here? Anybody at home want to chime in? All right, there's hills and SAS. Next thing we got to worry about for tomorrow, 30, 60, 90, 45, 45, 90 triangle. We got to review those rules. And don't worry about where it says operation with radicals. That's just a reminder for me I got to go over some stuff at the end with radicals for you. So let's start with my 45, 45, 90 triangle and the rules. All right, right off the bat, what do I know about the sides across from the 45s? They're always congruent. I call those the legs. I'm just going to, because they're the legs of a right triangle. And yes, number 1, legs are congruent in a 45, 45, 90 triangle. Legs are congruent. The other side, called the hypotenuse. Anybody remember the rule for that? The leg squared 2. Hypotenuse, yep, is equal to the leg times radical square root 2. There it is. There's your 45, 45, 90. Legs are both equal. Hypotenuse equals leg times radical 2. 30, 60, 90. A little bit different. Rules are a couple more rules. I'll put the 30 here and I'll put the 60 here. There are 2 legs, but they're not equal this time. There are 2 legs, but they're not equal. So what I'm going to do for you guys is I'll call the one opposite 30. The leg opposite 30, that's my shorter leg. And the one opposite 60 will be the longer leg. Again, the shorter one is always opposite 30. Don't think the shorter one's always on the bottom. No. It's always across from the 30. Alrighty. Rules. Rule number 1, how do you find the longer leg? What times radical 3? Shorter leg, so I'll just put SL here. Shorter leg, yep, times radical 3. Please do not get that confused with the radical 2 in 45, 45. Keep them separate, please. Keep them separate. And then finally, what's the rule to find the hypotenuse? Yep, shorter leg, now times 2. And then here's the hypotenuse if you didn't know. All right, any questions on the rules? Because then I got to go over different things we could do with radicals on this test. because as you can see, the 45-45 deals with the radical 2, and the 30-60-90 deals with the radical 3. So I could ask you to do a couple things with radicals tomorrow. Any questions on the rules first? All right, couple things with radicals that maybe you can expect tomorrow, and I want to go over with you because I don't want to surprise you. Maybe tomorrow you may have to take radical 2 and let's say multiply it by radical 3 based on your rules. So I just want to go over a couple operations with radicals. So radical 2 times radical 3, you can multiply when different numbers are underneath the radical. What do we end up with here? Square root of 6. Yep, you can multiply those. So if that comes up tomorrow, it's doable. Second thing you'll remember. Zach, give me an even number other than 2.
4.
Okay. Say you take 4 tomorrow. Say you're in a 45-45-90 triangle. The hypotenuse is 4, and you need to divide it by radical 2 to get to the leg. You're not leaving it like that. You are not leaving your answer like that, and you're certainly not going to go to your calculator and give you the decimal version of that beast. How do I fix it to get it into the simplest form? Go ahead, Radhika.
Multiply it by another radical 2 over radical 2.
Multiply top and bottom, if you remember, by radical 2 over radical 2. Yep. Keep going. So on top, you'll get 4 radical 2. And then do we remember what happens on the bottom when you do radical 2 times radical 2? Just the number underneath. And if you get worried tomorrow, just do it in your calculator. Radical 2 times radical 2, and your calculator will tell you it's 2. But I will expect you to go one more step tomorrow than this. Divide 4 over 2. So the final answer I'd expect would be 2 radical 2. All right, so if you end up dividing by a radical tomorrow, we're not leaving it like that. Get the radical out of the denominator. Third and final thing I would expect you to do with radicals tomorrow, if it comes up, combine them, add them. So for instance, if I have that 2 radical 2, you have to add it to 16, to 2 radical 2, and to 8. Let's say it's a perimeter problem, and those are my 4 side lengths of my 4-sided figure. What are we doing from here? What can I combine? What can I not combine, right? So say I ask for the perimeter of a figure, and those are the 4 sides, and you need to combine like terms. What can I combine here? 2 radical 2 plus 2 radical 2? 4 radical 2. So 2 radical 2 plus 2 radical 2 gives you the 4 radical 2, and also I can combine 16 and 8, 24. And that's it. That's it. Don't try to be a hero and go any further. That's as far as it can go. Questions from you guys? It's right there. 30, 60, 90, 45, 45. If you have to use it tomorrow. Well, if I shouldn't, I'm not saying if you're going to use it tomorrow. I just wouldn't have spent 10 minutes there. Anything at home you want to go over? What's up, Radhika?
Can you post this on Classroom so we can look at it like tonight?
The notes?
Yeah, like what we're writing right now.
I can. Yep. Just as like a PDF.
Yeah.
Yep. All right, next up. SOHCAHTOA, sine, cosine, tangent, but you better be working in what type of triangle? Yeah, we're not talking about sine, cosine, tangent at all unless you are in a right triangle. Same thing, with the 30, 60, 90 and Hills and Sass. All right, there's not much I have to go over here. Sine, opposite over hypotenuse. Cosine, adjacent over hypotenuse. And then finally, tangent, opposite over adjacent. I did want to review with you how to find an angle, because that's where some confusion comes in. So I'm just going to make up a random one here. 53 degrees. That's going to be, actually, I can't give you the angle. How about that's X? That's 16, and this is 20. Find angle X. All right, what's my 16? What's it to the X? Opposite, hypotenuse, adjacent. That's opposite, and the 20 is the hypotenuse. All right, you got opposite and hypotenuse. Which of the three ratios can I use here? Sine, yep. So I'm going to say sine X, sine of angle X is equal to opposite 16 over hypotenuse 20. And I know it's tempting to cross multiply, not here though. Not when you find an angle. Never you're finding an angle. Instead, when I find an angle, you got to go to your calculator and use the inverse of sine, cosine, tangent. And that's true if you're using law of sines and law of cosines too. Anytime we find an angle, I got to do that inverse. Somebody's got a question, but I can't see it. So go ahead. Just go ahead. What is it? All right. We're good.
I think Sophia had one, but then she got kicked out. I think she lost her Wi-Fi.
Okay.
No, my mic just wasn't working. So I know you said you don't use cross multiplication. Whenever I get a question like that, I usually cross multiply, so that would leave me with like 16 equals like 16 equals sine x multiplied by 20.
Yeah.
So then, but you can just skip straight to x equals.
Mm-hmm.
All right.
Yeah, because I think when you cross multiply, you think you're going to be solving for x, but there's no way you could solve for x by cross multiplying there unless you recognize that I got to do inverse sine. Okay, and then I go right again, second sine, 16 over 20. About 50.
Also, because I would just end up with 16 over 20 equals sine of x again.
Yep, exactly. So about 53 degrees. Questions from you guys? Anything there? Sine, cosine, tangent, finding an angle. We're all good. Got to be in a right triangle.
You said that thing about like sine of something equaling cosine of another thing, like that's not going to be on the test?
No, ma'am. Nope. All good? And I got, go ahead. What do you got, man?
Law of sines and law of cosines can be used on any triangle.
Correct. All right, I got more good news for you. I put angle of elevation and depression on there, but looking back at the test, it's not on there. Here's why I'm not going to worry about it. And this is probably going to be the best news for everybody. All the word problems, I've already done the diagrams for you. You do not need to make your own diagram for any of the word problems tomorrow. And in addition to that, I filled in all the, like I put, this is 58 degrees. This is 2.6 meters. I filled out all that in for you in the diagram. Okay, so you can focus on getting the job done. All right, everybody? So yes, you may see the term angle of elevation tomorrow, but I've already put that angle in the diagram where it should be for you. Hannah, go ahead. That's what we were talking about with cosine of 40 equals sine of the complement 50. Yep, that's what cofunction is. Yep, and not on there. I didn't put that on there. So is everyone good on the word problems, what I just spoke to you about? I make the diagram for you. I put in all the angles and the sides you need. You just have to figure out how to get my answer. All right? So good stuff there. And then last thing, so I'm not going to talk about elevation and depression because I filled it in for you. Last thing I need to talk about is what we've ended the unit with, which is law of sines and cosines. Again, not giving you that formula tomorrow. You have A over sine of A equals B over sine of B. And just give you a visual of what we're talking about, I have triangle ABC. A would be a side across from angle A. B would be a side across from angle B. And remember, A and B are just sides. You know, tomorrow it could be triangle RST. A and B are just sides. Yes, Ted?
How long do you think it's gonna, like, is the test gonna take us the whole period?
I would assume so, yes.
Okay.
That's my predict. That's why I only put 4 on there, because I didn't want to put any more, because I didn't think it would go
You said you
fast.
filled out all the diagrams, so that means it's probably gonna be harder.
No.
That's kind of what I got from it.
Because I did the diagrams.
Yeah.
Well, I'm not going to say it's tough, because you may breeze right through it and be like, hey, that was a piece of cake. All right. What I like about this test is those word problems probably can be done a lot of different ways. You want to use SOHCAHTOA? Maybe Maeve wants to use law of sines. Maybe Radhika sees a little Pythagorean theorem instead. Whole different bunch of ways. It's not like this is the only way to do this problem tomorrow. There's a whole bunch of different ways. All right. Yes, Radhika.
So wait, are you drawing the diagrams for all of them or just the elevation depression?
No, all 4 word problems, you'll have the diagrams already provided.
Okay.
Okay?
also,
And if I mention a side length or an angle measure in the problem, I've already filled it in the diagram for you.
got it, yeah.
It's up to you how you get to the final answer now. Okay?
Wait, on the like word problem thing on Classroom, there was this one thing with like angle of depression where you had to like add them. It's like said like it increased by like 4 and you had to add them. Well, that like it was really confusing because like they labeled it differently, but like
No.
Okay.
Everything will be clearly labeled, ready to go. Okay? So here's law, and also I wanted to mention this. I made a little note for myself. You can write law of sines like this, and I just want to show this to you because I think I did this on my answer key on Classroom. I could also write it starting with the sine of A first, over A equals sine of B over B. I just want you guys to realize those are the exact same things. Okay, and I didn't want you to freak out if you saw, why is he putting the angle on top and the side on the bottom? Because it's the same thing. All right, so I didn't want you to freak out if you saw that. And then finally, law of cosines. Oh, that's not what I wanted yet. Please know what A is not side A. We talked about that. It is the side across from the angle in the problem. B and C are the other 2 sides. Cosine A is going to be the cosine of the angle in the problem. Do not get in this mindset either. And everyone, do not get in this mindset. I'm not even going to use it tomorrow, law of cosines. Well, what if that's your only option on one of the multiple choices? All right, so make sure, I don't want you guys just to say, you know what, forget law of sines. I won't use it. I'll use something else. Well, what if it's your only option tomorrow on one of the multiple choices? Word problems, yes, you can get away with that thinking, but maybe not on the multiple choices. Maybe you actually have to use law of cosines tomorrow, and that's it on the multiple choice. So just keep that in your mind. I got one more thing to talk about before we end this discussion. Any questions from you guys on sines and cosines?
do you need like 2 angles for law of sines?
Correct.
And two sides for line.
3 sides. Remember, A, B, and C. Now, when I say 3 sides, Maeve, you may know 2 of the sides, and I may ask for the 3rd.
Oh, okay.
That's what I mean by 3 sides.
Couldn't you get 2 sides and 1 angle?
But you're still probably going to find the 3rd side.
Yeah.
Yep. Sophia, go ahead.
Is there going to be an answer key for the questions that are in the packet?
I'm going to get to that in a second. Yeah, they're already in the packet. They're located in
The
the packet.
answers?
To the ones in the packet, yeah.
All right.
Yep. Okay, last thing, and this is pretty important. Let's say, okay, I just drew this diagram up first period. You got a couple triangles in the same diagram. I told you CD was 6. I gave you 25 degrees, 30 degrees, and we're trying to find X. All right, I'm not going to do this one with you. All right, I'm not going to do this. The point is not finding X. Here's my point. Let's say you're like, hey, you know what? I may use law of sines to do this. So you know this is 50 because there are linear pairs. So that must mean this is 40, 180 degrees in a triangle. Let's see, I got 155, 25 degrees up here. So you found all the angle measurements and you're like, you know what? I'm going to do law of sines to find x. Here's what I got to make sure. I didn't do a good job of this when I did law of sines. When you plug in these 4 values in the law of sines, they have to come from the same triangle. The angles and the sides you use for law of sines have to come from the same triangle. Here's what I mean. Maybe you start off with 6 over sine of 25. Everyone see where I'm getting those 2 values from? 6 is across from 25. But you can't pull this on me. X sine of 50. Do you see how I got values from different triangles other than just one of them? That's not what law of sines is for. Law of sines, and cosines for that matter, is for values from the same triangle. All good? Everyone all right there? All right, so when you use law of sines, all the values, the angles and the sides, all have to be contained in the same triangle. You cannot mix and match from different ones. Radhika?
Oh, I was just confused. What would you use to solve this triangle?
This problem?
Yeah, you could use
Yeah, you probably have hypotenuse and BC.
I would find BC using this triangle here,
Got it.
and then transfer over to this one to find x.
Okay.
Is there?
You could do so.
Did you say BC?
Yeah, BC. You find BC.
Find BC, and then go to triangle ABC to find x.
And you do.
Yeah.
No, but like, what would you do with after you had BC? Because I thought you would use.
You could do it after you have BC. You could do law of sines again. You could do BC over sine of 90 equals x over sine of 50. You could do anything like 50. You could have opposite sine, opposite over hypotenuse. You could use the 40 and do cosine, adjacent over hypotenuse. So a lot of different ways there. Okay. But my main point there, guys, if you're going to use law of sines or cosines, all your values have to come from one triangle only. All right? Yes, Zach.
At the end, like if you have to find the side for law of cosines, do you have to do like the negative?
No, that's only for finding an angle.
Okay.
If you're going to find the side in law of cosines, you're probably going to end up taking the square root at the end. Okay? Because you'll be solving for a squared. All right. So, Sophia.
Looking at the questions that are in the packet, and I think this is in some of the word problems too. How much will we still will the properties and quadrilaterals and stuff come up again?
No. Again, all the diagrams are already. Maybe a rectangle might be on there tomorrow. Nothing out of control though.
All right.
Okay. All right. Before I end class here today, where can I go to study? You guys already know the problems up on Classroom. There's 15 word problems on there. Everyone, if you've got your packet with you, you can go to page 52 for me. Page 52. In the oval down in the left-hand corner, you will see textbook questions to try. All right? Those answers to those textbook questions are on the next page, page 53. And then there are questions actually in your packet, as you can see, starting on page 54. The answers to those are on the last page, page 60. Okay, so all the textbook and packet questions are already in your packet. All the answers to them. Okay, and hey, don't just spend time on the Google Classroom ones either. The ones in the packet are pretty good too. All right, the ones in the packet are pretty good as well. Because on Classroom, I didn't put any Hills or SAS on there. I didn't put any 30, 60, 45, 45 on there. Those are in the packet. Okay, those will be in the packet or in your textbook. All right, guys? All right, please get after it for me tomorrow. All right, I think you guys realize after today's review, don't take it lightly. All right, I'll be on at 4:20, and I'll post these notes up on Classroom later. Have a good night, guys.
What is PDF?
What is
Something
PDF
file.
stand? Yeah.
Portable document format.
Didn't have a file in it.
I know. I thought it. I definitely thought it would have been.
I suppose.
You just have to sit there, right?
Yeah. So, doesn't it get boring?
Batman? It's like this.
Oh, it's hard. What are you talking? What are you gonna be? I'll be out as long as I physically can. I'm going to
Never
I'm going to
ending,
use
right?
my
You think,
memory
like,
gadget.
I was out
first. Hopefully
I
the
was
I was out
recommending
for a long.
for
Wait, like this
every
happened?
second
No,
that
no,
they
no.
implemented
Yeah,
a year,
I think it's possible.
makes sense, but
No,
I
right?
didn't do my grades up, what do you think, like, is good? Well, I guess
Exactly.
that would be an opportunity to go on to the next year.
Well, it's really gonna be up to what you do the rest of the year. Like, I'm not gonna change things
I think
because
that
I've
also,
been doing
I
stuff
think
for a
it's
couple
10
weeks.
days.
Yeah,
You know what I'm saying?
what's a goal that I should reach for by the end of it? Like, what would be a grade that would
You
mean
should,
that I'm,
you should easily be 93 or above,
okay,
without a doubt.
Yep.
And now, I'm not saying that equals moving on to honors, but that's for you, Quincy, from what I've known you for, what you should end up with.
Alright.
All right? Hello, honey. Hello.
The quiz is today, right?
Yeah. Would you rather take it on paper or on your Chromebook?
I don't care.
It's up to you.
I'll take it on paper.
There you go, boss. Hopefully those work, all right? Let me know, all right? Please let me know.
Just start it.
Yeah, whenever you're ready. If you need, if you want colored pencils too, they're over there, all right? Right on the filing cabinet.
Alright.
Hi, Cam.
Hello.
Knowing you, I'm assuming you'd rather take this on paper than on your Chromebook?
Yes, please.
Okay. Straight edge, colored pencils all over near the file cabinet.
Okay.
Morning, Caroline. Okay, hi, Anna. Hi, Ella. Morning, guys. You guys are all set? Get going? And guys, I'm here to help you, okay? I don't want to see you struggle. First period struggled on that first one because the numbers were so big. All right, I don't want you to struggle. Feel free to ask me questions. I'll help you out as much as I can. All right, I don't want to see you struggle. I'm here to help you. And guys, I'm here to help you. Reach out. I don't want you to be scared off by those big numbers. Sorry about the lines there too, guys. It shouldn't be too big of a deal.